Good morning, ladies and gentlemen. Welcome to this session on innovation. We have a good lineup of speakers this morning. And the session title is How New Technology Can Impact the Bottom Line. Innovation leads to change leads to progress leads to changes to the bottom line. That's the theory. I'm old enough to remember how the potato industry was 40 years ago, and it's changed a lot since then, and I'm sure it's going to change more in the future. And we've got three outlines in quite different sectors as to how that might look in a few years' time. So the first speaker is Dan Milburn. Dan is a research scientist at Cheggis, where he has over 20 years' experience developing and deploying genome-based technologies for potato variety improvement. Cheggis have had an active commercial breeding program in partnership with IPM Potato Group Limited since the 1960s. This program has released over 40 varieties which distributed globally. Dan works to develop practical breeding technology for this program.
Thanks, Doug. This is a really exciting day for me in terms of the program because it's packed full of breeding and genetic improvement talks. So you might wonder, well, why did we put another one into the innovation session? And what we were going to try and do here with this is to try to give you what I described in my abstract as a hopefully contextualized whistle-stop tour of some of the more now or up-and-coming technologies and how they might interact in the currently or in the future to improve the breeding of the next generation of potato varieties. So it's a potato conference. I thought I'd start out with a picture of airplanes. But what I'm going to do here is I want to change or focus your perspective a little bit and to start to think of potatoes as not just a romantic food and healthy, nutritious food, but a potato is a machine. A potato is a machine that needs to do different things. And so I figured you'd all been recently fairly acquainted with this type of machine, and we don't have a problem with thinking of this type of machine, an airplane, as having a fairly detailed product specification. And we're also familiar with the idea that there's different ones for different jobs. That's fairly straightforward. You don't need even to know a lot about aeronautical engineering. If I asked you to describe the difference in function and form between these two things, you'd be able to do it fairly easily. So the other thing I want you to think about is, well, when you have a machine or a device, that you've got to build that device somehow in a production system. And if it's a device like this, it's got to be done to a fairly exacting standard because we don't like falling out of the sky from 30,000 feet. So the idea of a product specification for potato, that's not novel. That's been around for years. Breeders in the past have called this an idiotype. CGIAR really introduced this new terminology, referring to it as a product profile. And I like that because, again, it refocuses your attention on the idea that this is something that we're trying to build with a series of specifications. So I want you to think of potatoes as starchy machines that do different jobs. And, okay, they're maybe not as complex in terms of engineering as an aircraft, but there are lots and lots of things going on in these product profiles. So what determines the product profile? Well, first you might have something like the utility class. We've got table, processing, and starch potatoes, and then there's plenty of these niche and speciality potatoes. Even within categories, there are things like there's a very big difference between a table, a ware table potato and a salad potato. Those are clear differences. And within processing, you could be talking about crisps or French fries. So that's the end point, but then it gets more complex when you think you've got to grow the potato in the first place. And of course, as we've seen really comprehensively recently, we can grow in multiple different environments. But these environments have different specifications. They've got different production systems. They've got different environments. And those are adding to our product profile for potatoes. So if you're in you're here, if you're in this general area, you're producing potatoes in a spring production system under long days. There are all of these value chains present, so you're producing all of these types of potatoes. You're concerned about late blight and PCN and many other things. There are about we think the breeders will all tell you there's about 40 traits that they're interested in at any one time. They're not all equally important. Late blight and PCN are the most important diseases. And then we've got changes over time, so things like the farm-to-food policy, in which we're trying to reduce pesticide inputs by 50%, which is a really, really big ask, while at the same time we're eliminating all of the products that allow us to do that. And if you're in sub-Saharan Africa, you're in short days, 2 seasons, production seasons per annum. Late blight is important, but you may be much more concerned about things like bacterial wilt, and you need, as you saw from Hugo's talk, adaptation to these harsh environments in terms of drought, heat. And then if you're in Southeast Asia, again, short days, and this is the agile potato product profile, very early maturity to fit in between grain crops, heat and virus tolerance. And I really should have added one for South America to recognize the fact that CIP have done an incredible job in terms of breeding for micronutrients that is going to make a huge impact in people's lives. So we don't build the product in a factory either. Unfortunately, we build it in a glass house in the field, and unfortunately, I feel compelled to tell you a little bit about how we do that. So this is a kind of schematic that more or less represents the breeding program we run at Oak Park. So every year, we take 200 parents of the traits we're interested in combining, put them in a glass house, wait for them to flower. This is the only time we're interested in the flowers of potato, and identify pair crosses that we want to make to produce families of individuals from which we're going to select. And using this process, we generate, at the beginning of this process, over 100,000 candidate varieties. And then the rest of the potato breeding process is just figuring out which one or two of those could be a variety. And the way we do that is we spend 12 years doing it. Every potato variety that ever started, it started out as one true seed, and from that one true seed we get one tuber. So at the beginning of the process, there's not a lot you can do except put it in the ground and look at it. And the first selection that goes on is, does it produce another plant that produces tubers? So we start out with a lot of candidate varieties, and we do very little in terms of selection. And then as we go down through the years, and we eliminate varieties, but the amount of propagated material increases, well, we can do more complicated things. We can go from very simple visual selection to plot level selection to disease resistance and quality traits. And these are our trial sites that are spread all over, right from Ireland down to North Africa. And you get to the end of that process, and you've whittled it down from 100,000 candidate varieties to, you hope, 1 or 3 varieties. But importantly, each of these are only combining the traits of 2 parents. So for every time you turn this handle once, and it's 12 years, you manage to combine the traits of 2 parents. And this is what we call the recurrency of selection. And this is just the idea of, well, the product's profile, it can be a fairly big list of things. And if you're trying to do it in this cycle where you're only able to combine the traits of 2 parents at a time, it can be quite challenging. So we've got 2 major limitations in potato breeding: speed or time scale and precision. It takes 12 years to get from here to here. And a lot can happen in 12 years, and it's actually 15 years by the time you add a little bit of seed multiplication and post-registration trials on it. A lot can happen here. We want to get here faster, if nothing else, so that we can deal with the world a bit better. It's very difficult to make a strategic decision about what to cross here and wait 15 years and suddenly find what you've done is completely irrelevant. We also, potato breeding suffers from a lack of precision. We're not very good at hitting the product profile on all of the categories, and that's why we don't ever have the perfect potato. So I'm going to talk very, very briefly today about three ways we can do this, and I'm really going to try to get you to think of it in the following way. I want to talk to you about improving selection in the scheme that I just talked about, and I'm going to talk mainly about marker-assisted selection, and this is going to improve the speed and precision with which you can aggregate traits. I'm going to use disease resistance as an example. Then there's targeted intervention. I actually like just to call this genetic engineering and go back to the original term that we had for this, but it's based on a whole pile of things: transgenics, cisgenics, and now gene editing. You go to the novel breeding technologies session, you'll hear a lot more about that. And then fundamentally reinventing potato breeding in the way you've heard several times already by changing the genetic architecture of the crop to enable a more efficient breeding system. So in scenario one, which is improving conventional breeding, as I said, you've got this long selection cycle combining traits in pairs of parents only. And if I have 6 resistance genes here, these are all nematode resistance genes, and they all start out in single cultivars, and I'm combining them, well, each of these black arrows can potentially represent 10 to 12 years. So by the time I get down here, it may be 40 years later, and I've retired. And I don't get to see the product of that, and that's not really, that's not super good for me. So what we do in Oak Park in the breeding program, we've moved to what Jared was describing yesterday, is really incorporating marker-assisted selection into the program. And we deploy it around this stage. And what that allows us to do is to shorten the recurrent cycle of selection. So we get material that we can identify that has pairs of resistance genes. And then we can say, well, we'll let it go 1 or 2 more field generations and recycle it back up to the top as a parent. And so we're decreasing the recurrency of selection here down to 5 years, and we can roll this much faster. This is what genetic markers look like nowadays. They're not as exciting as they used to be, unfortunately. And the reason I showed you these 6 resistance genes is because I have a practical example. This is the potato variety Buster, which has all of these resistance genes in it and is very resistant to both Globidera pallida and Globidera stockiensis. And most significantly, from the point in time in which we thought to initiate this process to the point we got to Buster was really only the length of a single breeding cycle instead of the 3 or 4 breeding cycles it might have taken otherwise. In scenario 2, I like to think this at the moment of tweaking the profile in a targeted way. We have product profiles. I've presented them as an ideal thing that this is the list of things you want to do, but in reality, quite frequently, we start off with the variety and we build the process around it. So these are Fontan and Atlantic, which are processors. And then what happens is we build our processing factories around the characteristics of the variety, and then it becomes very difficult for potato breeders to get rid of those varieties and compete with them. But they're good, but they might have something wrong with them. So what we have is this concept of targeted intervention to enhance this things, and the sorts of things you can be talking about. And these are all real-world examples of increasing disease resistance, enhancing storage stability, and reducing mechanical bruising, manipulating the dominant starch type. And these can all be achieved, and this is basically what genetic engineering does. You add or upregulate or knock out a single gene or a couple of genes, and you get a pronounced effect. For instance, to increase disease resistance, you can add a resistance gene. To enhance storage stability, you can knock out invertases, which convert starch to sugar. To reduce mechanical bruising, you can knock out PPO in the tubers. And to manipulate the dominant starch type, you can mess around with starch synthases and change the ratio of amylopectin to amylose. And these are done, as I said. I'm not really going to go into any of these in any detail today. You'll get much better insight into them later. But you can, as I say, you can add or overexpress genes or knocking them out using various technologies. And the one of the moment, of course, is gene editing. The advantages of this is you can retain the variety characteristics of the industry standard, but fix it. The disadvantages, obviously, are there's a sort of there's been a public perception issue, and of course they're very subject to different levels of regulation in different environments, jurisdictions. I just wanted to give you some examples. This stuff works. It's now technology. This is some Desiree with a blight resistance gene from Solanum venturii in a trial we did at Oak Park in the context of the Amiga project. And you can see here Desiree, and we don't ever have to spray to inoculate for late blight in Ireland for obvious reasons. And you can see here, under those sorts of conditions, Desiree in the height of the epidemic, it's like this, and then the cisgenic version of it with the single R gene is like this, and this is sort of an aerial view. For The other examples I gave, of course, you're really aware of these innate potatoes, and this is a really nice example from a paper from Dennis Halterman. This is something with PPO upregulated in the tubers, and that's been sliced, and that's 24 hours later. You can see the buildup of oxidative browning here. It's quite pronounced. And of course, we had an early foray into this based on a disease resistance. With a whole bunch of BASF lines that were very, 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 sorry, that's a starch variety, that didn't really work out very well. And this is really this is from the US, this is from Europe, and that's a tale of two regulatory systems. If you want to get a bit more about that, go to Ewan Mullen's talk later on today. In scenario 3, and I'm going to go through this one really quickly because you'll get a better insight from that from two speakers in the next session. This isn't working out. Let's reinvent potato breeding. And in fact, one of the problems we have is that potatoes are tetraploid. It's got 4 copies of each chromosome, and it's an outbreeder. And without explaining the genetics of it too much, the rate of genetic gain in tetraploid outbreeders is relatively slow compared to the rate of genetic gain that you can get in a diploid inbreeder. Tomato, for instance, is a really good example of this. And the simplest way of explaining this is, well, you can see there's a certain amount of order in the chromosomes of a diploid. They're exactly the same, of a diploid inbred, they're the same. So when you do crosses with this, you get predictable combinations out the other end. When you make crosses from a tetraploid, you get chaos out the other end quite frequently. Crossing 2 very, very elite potato cultivars can give you quite surprisingly poor-looking material, and that's not an ideal starting point for that. So why not turn potato breeding into tomato breeding? And so we can do that. As I said, you'll get a better overview of that, but we can turn tetraploids into diploids. We can start selfing these diploids by the addition of the SLI gene. You heard a little bit about that yesterday. And then we talk a lot about the fact that it can be propagated by seed, but as Paul said, the real advantage of this is the speed and precision with which you can then hit the product profile. So using marker-assisted selection, recurrent backcrossing, you can shuttle resistance genes in there really, really, really quickly. I think you could probably do 4 or 5 resistance genes into an inbred within 3 to 4 years fairly easily. So the output of that at the moment we're going to talk about later is diploid hybrid breeding. You can develop these high-performing F1 hybrids, which are a little bit like hybrid maize, because these inbreds are suffering from inbred depression. So when you take 2 genetically distinct inbreds and across them, you get this heterotic effect, and that restores the vigor. This is the important thing. You get this high precision and the short time scale in achieving the product profile, and that's the really exciting thing about it. It's interesting, though. You can also potentially recreate your favorite hybrid variety with the traits. The one thing you can't do in potato breeding, if you've got a good variety using conventional breeding, is get that variety back with the additional trait, and the solution to that so far has been genetic engineering, but this can also do that. And of course, it can be propagated by true seed. I can't stand up here without giving a plug for a project that offers an alternative to hybrid breeding. It's kind of a halfway house between hybrid breeding and conventional breeding at the moment. So it captures this part of the process to make genetic gain efficiently, but at the last minute, instead of making elite hybrid, we cross diploids to tetraploids and magically come out with tetraploids at the end, because diploids can occasionally produce something called unreduced pollen. So if you want to talk a little bit about that, either go to this website or come and find me at the end. And this is a process where really we can shuttle in the genes that we're interested in from diploids into tetraploids using this approach. Why bother to create an alternative to diploid hybrid breeding when I said it's got such potential? Well, it's also got an incredible economic barrier to entry for SME-sized potato breeding companies. If you look at the manner in which it's being pursued at the moment, it takes an enormous amount of resources, and we don't all have such deep pockets to enable us to do that. I'm willing for people to take me to task on that in a later session. So, I've been presenting these as individual things you can do to make breeding better. But that's not the way breeding works. Breeding is a system of systems. These are all not individual approaches. These are components in a sort of next generation round of breeding. And you know, I said it's got to be a product. Well, you've got to have a cool name. The trouble with that is if you call it potato breeding 2.0, then why isn't it 3.0? Why isn't it 4.0? So let's just call it potato breeding X.0. And what I've done is genuinely a whistle-stop tour, talking about only some of the types of things that we can do to get into this black box of a system of systems that will produce the result that we want. So we want to move from this, in which we're not hitting the product profile on all ticking all of the boxes, and we're taking a long time to do it, to this, where we're bang on time, we're bang on mark, and we're doing it very, very quickly. And in my last 10 seconds, what I'd really like to do is thank some of the people I work with. Primarily, I'd like to thank Dennis, who lets me play around in his breeding program. It's not Dennis's breeding program, of course. It's the Chagas IPM Potato Group breeding program, and it's you know, this is sometimes on a good day it's a dream job. I want to thank a really, really committed and brilliant potato breeding team at Chagascan. Please, these are some of our postdocs and PhD students. Please go and visit their posters. And at that, I'll stop boring you. Thank you very much.
Thank you, Dan. Remarkably clear, succinct description of a very complicated subject. And everybody hopefully is a lot wiser. Our next speaker, who's going to talk about intelligent technological innovations, improve quality and yield along the value chain, is some distance from the DNA of Dan's talk. We have a specialist in agricultural machinery, Franz Bernd Krauth, who's studied agricultural machinery and technology and business administration. He started his career in Grimme in the sales department in 1992. Besides the responsibility for various sales territories, he was also a driver in product management and the expansion of an innovative product portfolio. In 2012, he took over the position of sales director and further expanded the international sales network with a highly committed team. For the past few years, his core focus has been market development of the two largest potato producing countries, China and India. Thank you.
Yes, thank you very much, Douglas. Can everybody hear me all right? Yeah. Good morning again, also from my side, and greetings from all of the Grimme team. Yeah, it's a pleasure for me now to give you some insights about technology developments. I'm not talking about breeding, even though I may make one cross breed at a certain spot. Yeah, here you see a photo of how it could look in the future, but of course it will be a little bit away until we are exactly there. Yeah, before I come to the solutions along the value chain, yeah, I will just show quickly the value chain I'm looking at. Then I also just would like to highlight some of the challenges farmers are going to change or are facing right now, because this is very important to have this in mind. Yeah, before we then have one chart of the average potato yield, and then I come to the solutions. Yeah, the value chain I'm going to look at is really right from soil preparation until the potato get into store. I'm not looking at the area after the storage until it comes into the supermarket, etc. I really look from the beginning of the soil preparation until the storage. It will start with soil preparation, which is really very important. Then it goes to the planting. After planting, I will look at the ridging side of the growing potatoes. Then at irrigation. After irrigation, I also have a quick look at chemical crop care, what will be possible on that side in the future. Then harm destruction, which also will become more important in the future. Then the harvesting side. I also don't want to get the transport side or the logistic part, as this gets underestimated, in my opinion, many times before I come to the storage equipment. Yeah, so this is the complete value chain I'm looking at, and I will keep this in the bottom of my following slides, so you have always an idea where am I during my presentation. Right, if we now look at the challenges, climate change. We did hear this many times. So temperatures will go up in the future, and this will affect really the complete growing season from the beginning of the soil preparation even up to the storage. Because if the temperature goes up and we have to cool down the potatoes, it will have also effect on the cooling of the potatoes and keeping the quality of the potatoes in the store. Then we have seen a similar slide this morning already. We will see droughts more often in the future, but also we will see more heavy rainfalls. If it then rains, we really face more extreme rainfalls than we've been used to in the past. And this is not only in extreme countries, even in Germany. Many of you have probably seen the photos and videos. Last year we had extreme rains, and this is something we really have to keep in mind for the future. Yeah, one other big problem is going to be the reducing amount of chemicals in the future. It will start that some of the major active ingredients got banned or will get banned in the next 1 or 2 years. Besides of that, there are also a lot of efforts from governments that the amount of pesticides has to get reduced. For example, the EU wants to reduce the amount of pesticides farmers are allowed by 50% until 2030. 50% less chemicals than what gets used now. So this will have especially an effect on potato growing. As on potatoes, we use a lot of chemicals, a lot of pesticides, I have to say. We use herbicides in the springtime as well as prior to harvesting to kill the vines. We use insecticides, and here we can think about eelworm, we can think about leaf aphids, we can think about potato beetle. So if our chemicals fall away, this really is going to be a challenge. Yeah, and then we also use a lot of fungicides for potatoes, for early blight, for late blight, even for putting potato into the storage. Against silver scurf, against fusarium, fungicides get used. So if we really lose some of those chemicals and have to reduce the amount, this is going to have a big effect on growing potatoes in the future. Especially, I mean, we are an island now, and Ireland got hit really hard 1845 with the potato famine. When blight came into Ireland the first time, it shows what kind of effect all diseases can have, especially to potatoes. Yeah, then we come to the fertilizer. If you look at the amount of fertilizer we use now, also the amount of fertilizer will be reduced in the future, and there also aims to reduce it by half. So if growers will have to use the fertilizer, which then is allowed to use, more efficient to grow the potatoes and to get the yields and the quality they're looking for. Yeah, then we will have a reduced availability of labors. I just put some pictures up here. If you look at new markets where we have workers mainly really working in the field, picking up potatoes, etc., I've been in India just recently, where even in India, which have 1.5 billion people living there, they even struggle there in finding people as farm workers. And yeah, there we have to see that yeah, less people will be available. But also in emerged countries, we see the problems that farmers don't get employees to work on farms anymore. So there, farmers are looking for solutions that one person can always do more and more. So also there, the efficiency one person can do per hour has to go up. Okay, before I now come to solutions along the value chain, I just would like to show this graph, and thanks to Cedric Porter, who did show this graph already yesterday. It shows the development of the average yield worldwide from 1960 to 2020, which did go up, which did go up from around about 13 tons to 22 tons, and this is the world average, which we are seeing here. We will have a lot of countries on the emerging markets. We have seen also graphs earlier, which are around 10 to 15 tons still for the time being. And there I definitely see potential to get more yields in the future. But if I look at developed markets, I really think it's a challenge to keep the yields which we have now in developed markets. I don't see with just a challenge I showed already that there will be big potential to increase the yields in the future. Okay, if we now come to the solutions, first of all, I just brought one slide here, or try to give a very simple overview of digital systems and the connection of all the digital systems. If we look then at all the machines along the value chain, so we will get the connection via a cloud system to satellites, to weather data, to drones, many other things. And then this data will go to the computer, to the farmer at home. Then data gets sent to the tractor. It will get sent to the people on the mobile phone, so they can make the right decisions to increase the yield. I'm not going very deeply into that, but during looking at the different machines, I will highlight a few digital solutions there. Yeah, if I start now with soil preparation, I will go now along all the machines which in the bottom, starting with subsoiling. This is nothing new, but especially in new markets. I always see again the problem that the ground gets worked only 7-8 centimeters, 3 inches, and then they grow potatoes in there and wonder that they only get 15 tons per hectare. It's really important that deep rippers get used, subsoilers, to break the hard pan in the bottom and to make sure water can penetrate up if it is dry, and if it gets a lot of rain, that water is also able to penetrate down into the ground. So this many times in new markets really get underestimated in my mind. That's why I just wanted to highlight subsoiling as well. Then breaking clods prior to planting. We see a machine here for that. So it's a logical step before you fight with clods at harvest time, that you try to break those clods in the springtime already, so you don't have them at harvest time. And the soil, the potatoes also will get better connections to the soil for better root development. Yeah, stone and clod separation prior to planting. We're here in Ireland, and in Ireland, by far the most known system is that the soil gets destoned or separated prior to planting. That especially also all the stones get taken out to increase especially the quality of the potatoes. Yeah, and pre-ridging, especially in the northern countries, if pre-ridging gets done in the autumn, so that in the winter time the frost can go through the ridges, so we get a nice loose soil for planting. Yeah, planting, if we do go to planting now, I would start, now we are digital system with section control. Section control means that if the headland is in an angle of, for example, 45 degrees, that each row is driven in, these are the planting rows. Each row gets driven individually. And that at the end of the field, according to a GPS map, each individual element gets shut off. First of all, we save the seed, but secondly, we also don't have unnecessary potatoes in the neighbor ridges here, which then go out to the side, that you don't get the green potatoes, you don't get the amount of small potatoes. So this also increases the quality and yield in the headland rows. Yeah, then variable plant spacing. I have two slides in here. First of all, what we call clever planting is if we have spraying trucks, that the potatoes which grow next to a spraying truck, they get more sun, they get more rain, etc., more water, and they have the tendency to grow bigger. And to make sure that they are not growing bigger, all the potatoes which you see here in yellow are planted closer together than the ones which have neighboring rows. So this is a good way of getting more equal size of potatoes. Yeah, then variable application. And we have seen the digital solutions where we can have yield mapping, soil mapping, fertilizer mapping, all kinds. And the trick, and not only the trick, the difficult part at the end of the day for a farmer is with all this data to decide what is the right action, what is the right decision to do. Do I plant closer at certain areas in the field? Do I plant wider? Do I apply more fertilizer or less fertilizer? Do I need to send information to my irrigation system to adapt to the soil maps? This is the hard decision a farmer has to do then. Yeah, and then I added also the use of soil additives or growth promoters. This is a new area which was also mentioned in the previous speech. That special bacteria, fungicides, increase the structure of the soil, that especially with reduced amount of fertilizer, the plant is able to pick up this available fertilizer a lot better. So fertilizer doesn't get washed out. And from the technical side is the question of how do we apply these additives. All right, if we now move to cultivation, we talked about more heavy rainfalls, just a picture of how that can look in potatoes. We have seen even more severe photos earlier this morning. And yeah, one possibility of how we also can reduce the amount of water runoff is with using dicos, or we call it Terra Protect, where we have some mini rows in the furrows to stop the water running away. And the reason for that is not only stopping soil erosion, important is also if it does rain, that all the rain stays where it falls down and is available evenly across the field and not just running away in the low part. There it gets too much water, and on the higher spot we have not enough water. So also really to conserve the water at the place where it falls down. Yeah, then mechanical weed control with less availability of herbicides, this will become more and more important. Yeah, and just to remark here, this is also an ideal area for robots, as not big masses gets transported, has to get transported. It just needs a simple vehicle with weeding tools, so it's not a big deal to do. Irrigation. Yeah, one remark here that irrigation is extremely important, not only for keeping the yield or for achieving the yield, but also for achieving the inner quality of the potatoes. which also get underestimated many times, that irrigation is not only for the yield, it also is important for the quality. With irrigation or with water, one of my favorite questions wherever I travel is, how is the water supply? Where do you get the water from? Most of the time it gets pumped out of the ground, and then I hear that the water level in nearly all the countries of the world is going down step by step. That means we have to be more efficient with our water in the future. And here we can see a photo from drip irrigation, which is the most efficient way that it doesn't, or that only as little as possible evaporates away. So this definitely will be a trend, and maybe also an area for new innovations to develop systems with more water efficiency. Then if you come back to digital solutions, that also irrigation system gets connected to the digital network. And last but not least, on the fertilizer, on the irrigation, we talked also about the fertilizer part, that fertilizer also can get brought out via the irrigation system to really fine meter the last rate of fertilizer. If we now come to spraying, I mentioned that the amount of chemicals will get reduced in the future, and one way of reducing it will not get banned altogether, so we still will have a possibility for the next years of using chemicals, that we use spot spraying systems, that only it gets applied where, especially on the herbicide side, this is good to do, only where the weeds are. If we look at fungicides, there we have to broadcast. It's not going to be that easy to spot spray fungicides, and there is the question, how can we get the ingredient exactly to the spots where we want it, not only on the top of the leaves, also to the stems. And there will be an area for further innovations via airflow, other systems. How can I manage to get active ingredients exactly to the spots where we want it to? And this is also an area for the use of robotic in the future. If we now continue to harm destruction, harm toppers became way more popular after Regilone was banned with the ingredient diquat. And there is definitely the demand for wider harm toppers just to cover more ground in a short time. Then also flail and spray will become more popular again, that the biggest mass gets taken away by harm topper, but that we then have bench spraying after the machine and only can get away using 30% of the chemicals compared to using chemicals in a broadcast way. And this is also an area for new innovations. A lot of things get tried already, which is harm burning, which is electrical killing of the vines with 10,000 volt systems, which is harm pulling, which is undercutting of the ridges. A lot of things are getting tried in this area at the moment. If we come to the harvest area now, there I see really good further potential for separation technologies. We worked on a system called AirSap to take out as many clods and stones as possible, but also other electronic systems will have an interesting future. And I think we do not need to look only at picking out clods or trash. We also should look at what we call positive picking, that maybe the potatoes get picked away from the trash and from the clod. Then driver assistance systems, just for example, tractor implement management systems called TIM, where really the machine in the back is giving the signal to the tractor if the tractor has to go faster, if the tractor has to go slower, if the machine wants a little bit more RPM, if it wants less RPM, that really the machine in the back is giving the right signals to the tractor what to do. Yeah, then again, the autonomous robotic question. I brought a photo here of a study with a machine called Harvey 1. This is a one-row harvester which is driving autonomously. It still has 2 people on the machine for picking, and potatoes get collected in the back. So if this general system works for such a small machine, this of course can adapt it easily on a bigger machine, because the technology of driving vehicles autonomously is the same if you have a small machine like this, or if you adapt this to a bigger machine. Yeah, and I brought a photo here, also specifically for new markets. We are also looking of how we can use existing technology, but make it smaller, make it more adaptable for new markets. This, for example, is the potato harvester, which can get pulled by a 50 horsepower tractor, which gets built in our joint venture in India, especially suitable for tractors up to, or this can be operated with tractors with 50 horsepower engine in it. So we not only look at autonomously things. If we look at new markets, we really try also to look at the area for emerging markets, offering technology and mechanization solutions for the area of 50 to 75 horsepower. If we now come to the transport and the logistic parts, there's an increasing trend that the transport gets done via trucks, not via tractor on trailer anymore, via trucks. The distances between the field and the storages get longer and longer all the time. Farms get bigger. We have to extend rotations, or farmers have to extend rotations, especially if chemicals fall away more and more. So the distances between the fields and the storage will become bigger. And therefore, I brought 2 photos here, just of a stationary field loading station, or what is quite popular in North America is, they call it a crop cart, a trailer which can get loaded in the field from the harvester, and then it can unload the load at the end of a field onto the trucks. And one thing which is also really important with loading in the field is the cleaning part of it. If we want to transport the potatoes to the storage, we do not want to transport the trash. Especially we do not want to transport the soil. Because the soil, there's always some diseases born in the soil. We want to leave all the soil in the field, because if this gets transported to the processing plants, and it will be even more difficult in the storage places, that this has to get disposed as special waste for a lot of money. So it's important that we do clean the potatoes as much as possible in the field to avoid spreading of diseases and the cost. Yeah, and then just a small point, optimization of the load weight. Road regulations get more strict all the time, that the transport vehicles are as low as possible in weight, and we try to load them as maximum as possible to use the maximum allowed weight. Yeah, last but not least, my last slide now on the storage handling side, or for handling equipment. There I see a bigger increase of, or a need for sampling solutions, because if you want to increase the quality, we need to make sure we check the potatoes by the time they get into storage. And if we then find out that the quality is not so good, that we make sure we store them separately, that they can get sold earlier, and that they are not right at the back at the end of the storage, so farmers can make the right decision with all those informations. Then optical sorting is an area which will become way, way more important, especially to save labor. on the storage side. And last not least, the size management for the marketing and the selling of the crop. It's really a very beneficial information if the farmer knows exactly what size portfolio does he have in store to market the size or to market exactly the volume of potatoes he has in the storage according to the size. Yeah, that was just a quick overview from technical solutions. I'm happy to answer questions later on in the sessions. Thank you very much.
Thank you very much. That was a fascinating insight into the advances. What I always find amazing is that the technology that's being developed for the rest of the world is then being extracted and applied to agriculture. I'm pretty sure that when people invented mobile phones, cloud computing, and GPS systems, they didn't expect it to be used to apply fertilizer and agrochemicals, but that's the possibility now. We're going to move on, and our next speaker is the James Bond of UK potato. I think you'll all know that in 007 there's an M and a Q. Well, this is the UK potato V. And if you can read V's name on the board, you'll see why everybody in the UK just simply refers to him as V. And he's very happy with that. He's an innovator and a co-inventor with over 16 years' experience in the fresh produce industry. He's an executive board director at Branston, which is one of the largest retail potato packers in the UK, and he has a full-time job doing that with a varied portfolio covering R&D, potato variety development, and IT. But he's also managing director of their small medium enterprise ag-tech businesses, Beehive Innovations, Harvest Eye Limited, and Root Extracts Limited. And he's going to talk to us about embracing agri-tech for step changes in the potato supply chain.
Thanks, Doug. Well set up for what it needs to. Very good morning, thank you. I don't know how you're feeling. I've been here since Monday, and it's been fantastic to see people in person, meet potato friends, and make some new acquaintances on the way from different parts of the country as well. So hopefully over the next 10, 15 minutes, I'm aware we are running a bit late, but I'll try to do what I can to speed it up. So first to start with, I'm just going to do a bit of an introduction on Branston, who we are, what we do, and the challenges that we face. And again, I think it's an emerging theme, and hopefully you will be able to think parallel to your businesses on the challenges that we face too. And our innovative approach, and approach is the key word here rather than the innovation itself, because everybody's onto the platform of innovation and we want to do something new, but how we think about it is something that I'm really keen to point out and labor on. Branston, we are one of the largest potato packers in the UK. We have 50 years in existence. We have 3 sites in the UK where the red dots are, and we work with 130 grower colleagues, and they're basically surrounded by where the sites are. So we procure locally and regionally where we can. We're proud to say we have about 900 colleagues who make it happen every day on these 3 sites. Roughly, depending on the crop year, we procure 350,000 tons of potatoes every year coming into our sites. And we also, not many people know that we also pack 100% of sweet potatoes for Tesco in the UK too. Why do I get out of my bed? Because of this. Our purpose as Branston, our vision, our value is that we want to leave what we find in a better place when we go. And in short, we just want to do the right thing. And it's very difficult sometimes to do the right thing. As we all know, as somebody who runs the business quite often, sometimes you need to be ambitious. Sometimes you need to put your neck out and say, that's what I'm going to do. And we've done that recently. There's quite a lot of talk about sustainability and how we want to survive and take the planet forward. We've put out there now to say by 2030, we want to be a net zero business. Frankly, I don't know how we'll get there, but sometimes you need to start acknowledging that there are things that you don't know, and there are things that you need to go and innovate and collaborate with an ambition that you need to achieve, and that's what we are all about. What do we do at Branston? We have multiple divisions. We pack fresh and potatoes and sweet potatoes. We also do ready-to-cook potatoes, so where we take microwavable pouch potatoes with some herbs and oils, all those sorts, that is convenience food. Not ready to eat, but it's more like ready to cook. We also do business-to-business, slicing, dicing, and peeling of potatoes to other businesses. We also have a variety and seed division where we, thanks to the previous speakers, we're quite looking forward to breeding potatoes quickly and satisfy our consumers in that aspect. We also have a very small farming division within the business so that we can experience firsthand the pains of what the farmers go through as well. We are well invested. We take pride in saying we continually invest back into the business. We have the state-of-art facilities when it comes to warm store conditioning, whether it's optical grading, whether it's gentle handling of potatoes within the sites, or the end-of-line automations, which we're all gagging for because of the labor issues that we face. We initially start with taking the best, make sure it is best, and we roll it all across the sites on all 3 sites. I'm not going to speak about any of this today in that particular detail because these things already happen. For us, as a packer who deal with grower base and the retailer, the context of growing potatoes and the challenges that we face. In the UK, roughly it's a 5 million ton per annum crop, 50-50 process and table. The consolidation is already happening within the grower base, either by necessity or by the market pressures. As you well know, it's a field rotation is very important, and it's a stored crop. And it's quite, the last point is very interesting because 50% of the crops grown on rented land. We have a fantastic conflictory objectives and challenges that we face, not complementary, conflictory. We want the lowest retail price for the product that we make. We want to make it affordable, but on the same hand, as the previous speaker was mentioning, a lot of chemicals being removed. We want the highest yield that mitigates the climate change that we are facing into. Not an easy task, to say the least. But there's also competition brewing up, whether it's a recent short-term issues of more people want to grow wheat than potatoes, or it's a wider opportunities to grow better yielding, better return crops. We want to make potatoes more relevant. But it's complex. And when sometimes you look at the complex things, you need to then come back to the basics to say, how do I crack this? Most of this are probably not in our control. Some of it could be in our control. Some of it we could influence. So we take that approach to say, look, what is it that we can change and we can face into to solve the problem? One thing that we took upon ourselves is the challenge of crop visibility. Yes, there are a lot of things happening, but do we understand, and do we really understand the crop that we grow and it comes to our factory? And that's something that I'm going to speak a bit more about. Again, don't need to remind ourselves of all the headlines happening around us just to make it more complex. When I initially spoke about the agenda, it's more about the approach of innovation. Yes, I'll show you a lot of innovation and other things that come with it. We realized very soon, if we have to be net zero by 2030, if we have to continue to lead the market in the UK, and if we have to face up to those challenges, we can't do it on our own. That's very simple to say. A lot of us realize that. We need to collaborate. That's the next step. The most important thing that we realized is it's very difficult to solve these problems if you think like a potato packing company. We need to change our approach, and that's where we differed. 5 years ago, we created a company called Beehive Innovations. The purpose of it was to take these challenges out of the day job of Branston and try to think of an innovative approach, the new ways to solve these problems as everyday issue that we need to face as an R&D company. There are 3 main reasons, I would say. The first one is the skills. There's quite a lot of buzzwords used: big data, insights, artificial intelligence, deep learning, machine learning, a lot of data points. There's big data everywhere, but not enough insights to make value. But we need young modern skills, emerging skills, futuristic skills people to come and work in the industry. We want to attract them into the potato industry. They're all very willing to go and work in Google and Apple. We want them to code for potatoes. We want them to code for food. And that's what we are trying to bring with this company. So we have 24 colleagues who are creating new technologies with emerging skills that they bring. There's no phone a friend to call and ask, how does this work? How do I make this? I've got a problem here. They need to figure it out. And therefore, we are attracting the new skills. And that's what this industry needs. That's what we need in the potato industry. Bring those futuristic young skills to solve these futuristic problems that we have. That's the first thing. The second thing is collaboration. I can put a lot of names in there, but I just selected few. And again, we got to open up. We got to open up and ask the question and realize that we don't know these answers. How can we collaborate with the universities? How do we take that brain power of universities and the research papers and the PhDs and the postdocs and the patents they have and see how we can make use of it in the industry and apply that into the industry to solve these problems? Thirdly, you can have both of those, but if you don't have enough money to solve this, it's not going to happen. And really, thanks to UK Innovate funding, we've been fortunate enough to attract about more than £6 million worth of funding in the past 5 years just for potatoes. And that's the biggest funding for one single crop in a country that we've been able to do that. And really, thanks for the UK government to put that research and development money into a staple crop like potatoes. Our purpose, got to make potatoes tastier. We want people to come and buy potatoes again and again. We want to reduce food waste, straightforward. We want to increase yield, but what I'm really keen about to emphasize here is not the pop talk yield that we all have to say, oh, I got 50 tons of that field, or I got 100 tons of that field, but how much did you really get paid for the 50 tons that you harvested? It's the marketable yield that we want to speak about. And it's adding new value in the supply chain. How do we keep those potato growers growing potatoes for the next 50, 60 years, 100 years? How do we bring in new supply chain, new value into the supply chain? And that's what we are keen about. And hopefully, I'll show you some examples on what we are thinking, how we do it. The first challenge, as an example, is all about crop visibility. Size matters in potatoes, I've been told. Potatoes grow in different size and shape, but how do we understand what exactly do we have as a marketable product? We've come up, we really started to develop and innovate, but we ended up inventing a new system called Harvest Eye. I'll let the video explain what it is. It's bound to happen. So from a Branston point of view, the problem here was procuring from 130 growers 350,000 tons of potatoes. We wanted to really understand what the marketable range is. And I'll give you a very simple example. We often get cold weather in England, as you might know. We want to run a promotion on baking potatoes, and there's a particular range of size that we are looking for. And to make those products for that particular size range, we always end up chasing quite a lot of other sizes of potatoes that you need to market. So we call it crop imbalance, and we want to utilize every single crop that we can, and that's the whole purpose of it. By having these systems now at Branston, we're now being able to look at forward, at the time of harvest, what's the stock we have in the stores, therefore we can plan effectively. And we'll also be able to look at the sustainability issues that come with what's the right variety, what varieties are yielding the right sizes, and where in the field the variation is happening. Therefore, we can work with our growers to reduce the variation. The second challenge that we are working on is the wireworm. Again, 3-4 years ago, this was not a big topic in the UK. Currently, you can't have a conference without speaking about wireworm in the UK. We are now employing camera technology and, again, machine learning. We are teaching cameras to learn what is an earthworm and what is a wireworm in the field before planting, with the view that we could provide some insight to the growers, either to say, there's quite a lot of wireworm in that field, so please don't plant, or there are certain areas in the field where we have found wireworm. Keep in mind this is pre-ridging, and therefore we can help the farmer make the decision to say, should I have a very decisive and very precise traps in certain areas, or a different method of dealing with that particular problem rather than dealing with as a blanket issue, as the chemicals that are used to control these are disappearing very soon. So that's, again, we are using technology like camera systems and artificial intelligence and deep learning to provide insights on where the wireworms are in the field. This is very interesting. We have a project called TuberSense. The challenge here is you harvest the potato, it's a stored crop in the UK, and when you bring it out 3 months, 6 months, 9 months later, you're disappointed. Either it's rotten up, it's got some black hearts, it's got some internal defects that's developed during the storage, or there are a number of defects and disease that happens for various reasons. But the point is, it's a bit disappointing when it reaches the consumer that we can't see, especially internal defects. Again, we partnered with the University of West England in the UK, and we've been working on this project for the past 2 years, and we have further funding to do it for the next 3 years. This is all about sniffing potatoes in the stores. What we do is literally sniff on the volatiles that's emitted by the potatoes, and every single defect and disease has a signature volatile or signature volatiles, sometimes in plural, making the challenge a bit harder. So the project's all designed to understand what is a specific signature volatile for specific disease and defect, and we then go about creating sensors that work on sensitivity that it can detect early. So in other words, if you are seeing a specific volatile for black heart and you are seeing it in very high sensitive, i.e. at the time of it happening, beginning to happen, I'm speaking in parts per trillions, not parts per million, you can then use the sensors to say, hey, in this dough, I got something happening, I'm detecting these volatiles, please take this stock and use it before it becomes a problem. And therefore we can reduce the waste, therefore we can use the crop better. And we want to make every tuber count, is what we say simply, and this goes a long way in proving that. So we again, speaking about skills, attracting the right people, we got a postdoctorate working on this full-time with the University of West England. You saw the video on the harvest eye. That's all about sizing information and field variation on a single field. We then push the boundary to say, could we understand the size of potatoes in every single box that goes into a cold store? Or, take a step back, could you understand the exact size that you got in every single store? Why? If you know that, you can then basically open up the stores in the right order to match your demand and be a bit more smarter about how you utilize your crop throughout the season. And there you're seeing 2 different stores, 2 different size parameters, and you decide what it needs to. So we call it a smart store, and that project's also in progress. So far, I've spoken about various things that happens after the crop is grown, during the harvest. Still good, but it's not as good as something that if we can understand the crop, the holy grail, can we see potatoes whilst they are growing under the ground? Therefore, we can have meaningful intervention.
Hi, I'm Effie. I am the TuberScan project manager for Beehive. The challenge that we're trying to address with TuberScan is that growing potatoes is very much not precision agriculture, and it can be really difficult for growers to understand what's going on underground. Current practice is that they'll take samples of their crop and they will extrapolate that data up to provide the whole picture. But actually that can be inaccurate due to crop variation. So we thought, why use this labour-intensive sample data when actually you could be using technology to get data on the whole field? So that's what we're trying to do with TuberScan. So we are combining above and below ground sensing technologies to provide crop variation across the whole field throughout the growing season. This insight on the whole crop variability will allow growers to make data-informed management decisions and increase the marketable yield of their crop.
This is an ongoing project, and this will finish in Feb 23. We've got 2 prototypes that we've created that we are testing hopefully in the summer, this in the UK. The paradigm shift here is why use samples? I'm not saying we don't need sample data anymore. We will use it for ground truthing. What we really need is use technology, pull the technologies that's available from different sectors to solve the problem, to understand the whole crop variation. In this particular case, the technology answer came from Ministry of Defense in the UK. So the radar that we are using are the same radars that they used for IED bomb detection in Afghanistan. And it came by chance from the university discussions, and I invited them to come and spend a half a day with me in the field in potatoes to see whether the feasibility of that could be done. And 4 years later, some good money spent on different research and getting it to the stage that we need to, we are now in a position where we can see underground, and the colleagues are working on how to change that signal into meaningful information that we can relay to the farmers. And quite often, this is again going back to the approach, the problem that we are trying to solve, the solutions lie in different sectors. So we need to keep our eyes and ears open on what else is happening in different sectors, and how do we cross-pollinate those solutions into our potato sector? And that's something I'm very keen on. I spoke about adding value in one of the purposes that why we do what we do at Beehive. I've explained, look, Branston does, we got fresh potatoes, we got secondary potatoes, and everything else that left over in a typical way goes into a feedstock. We try our best, we slice and dice, we peel, but what we've created very recently is potato protein coming out of outgrade potatoes and peeling pulp. Plant-based industry is growing. The demand for plant-based, clean label, functional protein is ever so increasing around the world, but there are not enough raw materials to satisfy. If you're a plant-based vegan, you look at the ingredient list that you get on the packs, it's a chemistry box, and it's full of stuff imported from here, there, and everywhere, because that's how they make it now. But what we are playing into is creating regional-based, using regional-based. So for example, in the UK, we will use UK-grown crop that has got crop residues or crop leftover, which is stock feed potatoes, take them as a raw material input, and we created a process that then converts it into a potato protein, clean label, functional potato protein to go into the UK plant-based industry as a food ingredient. We grow crops, it will end up with the human supply chain, and that's the key ultimate thing that we want to do. We call it root extracts, and the concept here, again, the approach is, we are not doing this just to create protein. I take the approach of potato biorefinery. We call it potato biorefinery. It's similar to a refinery of oil. You got potatoes, you take that as a raw material, you got starch, you got protein, which is 1 to 1.5%. Then you dig deeper, it's very low volume compounds, very high-value compounds that we can create for both food industry and pharmaceutical industry going forward. And that's what we are looking in this as root extracts and protein production. So hopefully I've given you enough examples of how we think differently and how we are pulling different technologies to different things. So if I just kind of put it together as a summary, we want to understand the crop, size and count. We want to understand what's gone into the store. We also want to understand what happens in the store to the quality of potatoes, and how do we get there before the crop is not being useful. Want to help growers where we can in the latest issues that we face using technology. Hopefully the holy grail, as it might be, to look under the ground whilst it's growing, to have some meaningful intervention so that we can provide those data inputs to the precision agricultural equipment manufacturers in the future, and to bring some new value, new added value into the potato supply chain so that we can keep the potato growers growing potatoes sustainably for a longer period of time. By doing that, we can plan better and we can reduce waste. Thank you. Looking forward to some good collaborative conversations later. Thanks.
Thank you very much. I think you could maybe agree with me that he's more Q than V. It's like being in a Bond movie when you get all the new equipment that's going to be coming on offer and how to work it. But three fascinating speeches, and hopefully we can manage, with your will, to take this another 5 minutes of questions. That would get us to past. It'll leave you 50 minutes for coffee. So, is there anybody who would like to ask a question? They do have stands. Each three speakers have got stands out in the building. I have a question somewhere. Yep.
Hello, thank you for the interesting talk. My name is Gidi. I'm from Israel, working for Netafim, a precision irrigation company. Actually, France, you show one of our photos. Actually, it's been taken in France 15 years ago. So drip is already exist, step by step, and I hope that you are correct, that in the future drip will be the trend. But my question is, it's more general about the adoption of innovative solutions within the farmers. You present many new technologies, and this is the talk in the industry. In the end of the day, farmers find it very hard to adopt because of the mentality, because it's a conservative sector. And we see that if there isn't any incentive, if there isn't any support, nothing is going forward. Do you see, let's say in the European era, in the regulator, someone that taking care of it, some support, some subsidies? This is from the, let's say, from the governmental point of view, but also from a companies like Branston, for example. Personally, I know few Branston growers in the UK that are using drip irrigation, but there is any support also from Branston or other companies like Branston that give some incentives to the growers to adopt new technology, that of course innovation is usually go together with sustainability. So is there any support, any programs?
I think either V or Franz Perez.
Or maybe, is it working? Is the microphone? Yeah, okay. Yeah, you're right, I should have mentioned that one challenge of drip irrigation is, of course, that it is labor intensive, and that this is a challenge also to see, is it possible to mechanize this a lot better? So the adoption will be easier for many farmers, especially in the established market, where the labor costs are higher. This is one of the challenges which we're facing there.
Just to add on the general aspect of your question is, like the adaptation of technology within the farmers is slow and it's very challenging. It's not surprising, I would say, because again, it's all about value derivation. There's a lot of pretty pictures and how can I see the value? How can I see that bottom line increase? And you're absolutely right that the whole supply chain needs to do what they need to do, whether it's a packer, processor, retailer, or the farmer. It depends on where the value lies and who's paying for the cost. And that's the typical conversation that you have in any supply chain to say who's the biggest driver of the value. So for each and different technology that I spoke about, it depends on what it's used for and where it's used for and who's the biggest driver of the value. And usually the market forces make those packers, processors, farmers, whoever it is, the biggest driver, invest in those technologies as a leading people first. And then it precipitates and the ripple effect happens. But I think there's a very casing point here is quite often we're all getting carried away with the technology, whether it is, again, the camera systems or whatever the robots and everything else that we want to employ. But most importantly, we are now shifting towards how can you make technology a bit more adaptable to the farmer? The farmer wants to farm. He doesn't want to play with drones or want to fly drones, but they want the insight, they want the information. It's bridging that gap, and I think there's quite a lot that needs to be done in doing that. Government subsidy, again, if I speak for UK, there's quite a lot of innovation, farmer-led funding that the government is giving to the farmers now, where they can participate with companies and research universities to get on with solving the problem, but also to break that barrier of technology adaptation. So that I'm seeing, thankfully, in the UK at least.
Okay, thank you.
Very good. We have another question here.
My name is Paul Struik. I have a question for Dr. Kloethoff. Thank you very much for your very interesting presentation. And because of climate change, the growing season in many parts of Europe have actually become much longer by about 4 weeks, both at the beginning of the growing season, it has been extended, and also at the end of the growing season. Farmers do not use that longer growing season because of the heavy machinery and therefore the workability of their soils. Do you have any suggestions how we can actually make profit of that longer growing season?
Sorry, if I may just can ask why they don't make use of the longer growing season?
Yes.
Yeah. I mean, most farmers I talk to, they try to get the potatoes as early as possible in the ground, so they get as much as possible moisture. During the summer, we really have, we always struggle with drier weather. Even in the springtime, we face more and more drier periods, and that's why most of the farmers just try to get their potatoes into the ground as early as possible, to get them off to a good start with hopefully as much moisture as possible. But especially the processing varieties to achieve the size and the internal dry matter and quality, they take a little bit longer. And those are usually the French fry growers which are harvesting towards the end of the season. And some of them also do really plant the potatoes later. But that's the explanation I would have for that.
Super. I think, given that you've had a very long morning, if you've been here since 8:30 with almost no break, we should let you have a coffee. So all three speakers have all got stands out in the hall, and I'm sure would answer any more further questions out in the hall. But up until now, could you just give them a round of applause to thank them for very entertaining talks?